All right, this is Thursday, June 24th, 2021, Math 3 Summer School Period Spring Term, trying to understand everything about radicals and radical functions and radical exponents in preparation for tonight's killer homework. To begin with, a radical is the sign here. The index is hopefully an integer, but not always, that goes underneath it. If nothing is written, it's implied that the index is 2, meaning take the square root. Whatever number is underneath the radical sign is called the radicand. In this first example here, they ask, what is the real number root of 144? You're hopefully memorized some multiplication table in the past, recognizing that 144 is 12 squared. Therefore, the square root of 144 is 12. This is called the principal root because if I put in negative 12, turns out that a negative times a negative is a positive, and negative 12 squared is also 144. So sometimes there exists a principal root and a negative root at the same time. When you are dealing with something a little trickier, like number 7 here is asking, what is the cube root of negative 27? What is the cube root of negative 27? Well, 27, we hope you recognize, and if it takes you a while to figure it out, you ask yourself, what products create the number 27? And maybe you would think, 9 times 3 creates 27. And all right, what creates a 9? 3 times 3 creates a 9. So 3 times 3 times 3 is 27. Well, that's 3 cubed. They're asking, what is the cube root of negative 27? The cube root of negative 27 is the cube root of negative 3 cubed. And the way that works is negative 3 times negative 3 is positive 9, and then positive 9 times negative 3 is negative 27. So even though there's a minus sign underneath the radical sign here, there does exist a real root for this situation. The cube root of negative 27 is negative 3. Now that's the only real root. If I try to plug in x equals positive 3, I won't get negative 27, I'll get positive 27. So in this situation, there's only one real root. Yeah, okay. When they ask you to simplify a radical expression, like they're doing here, number 21, it says simplify the square root of 81 times x to the 4th power. But when do you use absolute value symbols? It says only use them when you need to. Well, when do you need to? Yikes. So to explain that one, let's work through some of these right now. Where basically I'm going to show you my solution, and then, I don't know, we have to move on so fast today. So I'll try number 21. The square root of 81 times x to the 4th power. Whoops, all blurry. They want you to simplify this. Again, if nothing is written here, then it's presumed that the index is 2. In other words, they're asking, what is the square root? Which number times itself will give us the radicand? from your members, multiplication table of your youth, 81 is 9 squared. X to the fourth power is x squared quantity squared. So the square root of 81 times x to the fourth power is going to be the square root of 9 squared is 9. The square root of x squared is x squared. And we're just about done. But you should ask yourself, is there any situation where any of these terms might be a negative number? Are there any conditions when 9 is negative? The answer is no, it's a positive 9. Are there any values of x that would make x squared a negative number? And the answer is no. As long as that answer is no, you do not need an absolute value sign. So this is fine. This is the simplification of problem 21. Now I'm going to try problem 22. Problem 22 says, what is the square root of 121 times y raised to the 10th power? From your multiplication table of your youth, we hope you recognize that 121 is 11 squared. From the rules of exponents and stuff, y to the 10th power is y to the 5th power squared. So we're going to take the square root of 11 squared, and we're going to take the square root of y to the 5th power squared. And that will give us the square root of 11 squared is 11. The square root of y to the 5th power squared is y to the 5th power. But here's the thing. Before you put a box around this and say, oh, I'm done, you have to ask yourself, is there any value that could make this a negative number? For 11, the answer is no. 11 is a positive number. But for y, the answer is yes. If I put in y equals negative 1, for example, raised to the 5th power, that would be negative 1 times negative 1, which is positive 1, times negative 1 times negative 1, which is, again, positive 1. But the last one is going to make it negative. That 5th occurrence, that odd number of y to the 5th power, is going to make this whole value potentially a negative number. And in this part of the course, we're not trying to take the square root of a negative number unless it can work out exactly right, like this example with negative 27. Here we could take the square root of a negative number. We got negative 3. I'm sorry, is the cube root, not the square root. The cube root of negative 27 was 3. But trying to take the square root of a negative number, it's not going to work out. So before I say this is my final answer, I need to restrict the values of y and make sure that they are never negative. I do that by adding absolute value symbol around the y. Don't put it anywhere it doesn't need to go. Don't put it around the 11. Don't put it around the 9 or the x squared in the previous problem. Only put it where it needs to go to be correct. So here is my answer to number 22. And just to be safe, I'm going to go look up the answer key in the back of this book and verify that, yes, I know how to do this stuff. I got the right answer. We should move on. Number 27, 22. Oh, I got the right answer. Okay, I'm going at ludicrous speed. I'm going to pause right now. Oh, man. Okay, I forgot to record for a couple of minutes. Right now, we are doing what's called problem. Well, I did problem 26, the cube root of x minus 9 quantity cubed, and established that it can have positive or negative roots matching the sign of whatever is underneath the radical sign. So the solution for that one was just x minus 9. Now I'm doing number 28, which asks, simplify the cube root of 64 times x to the ninth power divided by 343, all underneath the radical sign. The cube root of 64 is 4. The cube root of x to the ninth power, so I divide 9 by 3, and I get x cubed. The cube root of 343, my calculator told me that is 7. And now I have to pause and ask myself, do I need absolute value signs anywhere? Is there any situation where this number might be negative and the original number might not be negative? I guess that's how I would phrase it. For the 4 and the 7, no worries. For the x cubed, why, yes. If x is negative, then x cubed is going to be negative. And over here, it's an odd power, which means this could also be a negative number when I get done raising it to the ninth power. A negative number to an even power is a positive number. A negative number to an odd power is a negative number. So if this starts off being negative, this will also be negative. And I am comfortable that the cube root of a negative number can be a negative root. That is fine. So I claim, here's my answer to problem 28. I'm going to flip in the back of the book, and it says problem 28, answer is 4x cubed over 7. Ta-da! Great. That is a whirlwind tour of simplifying radical expressions. You only use absolute value when it's necessary. And necessary means you have an odd power root and an even powered radicand. Okay, that's my claim. Let's move on at ludicrous speed. How do you multiply and simplify radical expressions? All right, I'm going to demonstrate it. When you multiply, you may, try to find common things. So number 1 here says, what happens when you multiply the square root of 4 times the square root of 6? Okay, well, if you're not sure how the rules work, pick something where you know how the rules work. Okay, so for example, you should know that the square root of 4 is 2. And you should know that the square root of 9 is 3. So as a little test for yourself, ask yourself, what happens when I multiply the square root of 4 by the square root of 9? And on the one hand, you should say, well, that's going to be 2 times 3 is 6.
Mr. Chard?
Yes.
It's 6. It's not 9.
What?
yeah.
I'm not following you. The square. Oh, yeah. No, I'm not doing this problem right now. I'm saying
Oh, okay.
stand by. Okay, stand by. And do a problem where you know what the answer must be. And so suppose it's the square root of 4 times the square root of 9. You know that the square root of 4 is 2. You know that the square root of 9 is 3. And so 2 times 3 is 6. Now, the other way you can get there is to combine the terms underneath the radical sign and ask yourself, what is the square root of 4 times 9? 4 times 9 is 36. And the square root of 36 is 6. So what I'm trying to show you in this example is that this operation, this math operation, is allowed as long as the index is the same value. In this case, they're both square roots. You can rewrite it this way. So in other words, the square root of A times the square root of B is equal to the square root of A times B. So back to this problem number 1, the square root of 4 times the square root of 6 is equal to the square root of 24. Now that doesn't do much for us right now. We still need to simplify it, okay? So another way to get to this value is to break apart the 4 and the 6 and say, what is that? Well, that is the square root of 2 times 2 times the square root of 2 times 3. 4 and 6. So now I can multiply all of these underneath the radical sign. 2 times 2 times 2 times 3. That is the square root of 2 squared times 6. I guess I would write it that way. I can pull the 2 squared out of the radical sign. And so my simplified number is 2 radical 6 is my final answer. 2 radical 6. I guess that's a long-winded of saying, okay, the square root of 4 was 2, and I couldn't simplify this any further. So 2 radical 6. Sometimes, though, I'm just going to keep going. Let's do number 2. Number 2 says, what is the square root of 9x squared? You can't see number 2. What is the square root of 9x squared times the square root of 9y to the 5th power? Oh, well, okay, you can combine them underneath the radical and write this as 9 squared x squared. Now for the y to the 5th power, you can break that apart and call that y to the 4th power times y. And now pull these first 3 terms out of the radical. The square root of 9 squared is 9. The square root of x squared is x. The square root of y to the 4th, so I'm going to divide 4 by 2, is y squared. And what's left underneath the radical is the square root of y. Now, one more thing. Do I need absolute value signs? If y is negative, then y to the 5th is also negative, and that part is okay. But if x is negative, we're in trouble. Let me think. Is that right? Maybe we're not in trouble. I think we're in trouble. This number is never negative. But this says it can be negative. So I believe that I need to put absolute value symbol around this. Let's go see. This is practice 7-2, number 2. What does the answer key say? It says there's no need for an absolute value symbol. That it's just 9x squared, 9x y squared, radical y. Okay. I guess that means assume all variables are positive. That means I didn't need to worry about it. Okay, we're about to be at the halfway point in this period. I'll leave one of these displayed, and in 3 minutes we'll come back and do it. Okay, I'll just leave these displayed, and if you want to try any one of these, 3, 6, 3 or 6, you're welcome to it. See you in 3 minutes. All right, kids, 3 minutes have gone by. Come on back in. Come in, come in. Camera's turned back on. Yeah, on my screen, this stuff is poor quality imagery. I can kind of read it, but I don't like it, actually. In terms of quality, I dislike it. A little curious. Where's my wheel? Joshua Kim. Oh my goodness. Joshua Kim.
Roger.
Did you want to bother trying to do any of these problems? 3 or 6?
I'm having trouble understanding it.
Okay, yeah. I'm displaying 2 problems on the screen. Do you want me to bother doing either one of them?
Yeah, can you do number 3?
All right, number 3. It says the cube root of 50 times x squared times z to the 5th power, all underneath the radical sign, times the cube root of 15 times y cubed times z. Huh. All right, so this is number 3, problem 3. Because they are both cube roots, we can combine them. If one was squared and the other was cubed, we can't do anything about it. So this is going to become the cube root of. Now for 50, I'm thinking in my mind, how do I simplify 50? 50 is 25 times 2. 25 is 5 squared. So 5 squared times 2 is another way of writing 50. For the x squared, there's no other x, so that's going to stay as an x squared. For the y, there's a y cubed. For the z, there's z to the 5th, and over here is another z. So that's z to the 6th power. There's a 15, and instead of writing 15, I can break that into 5 times 3. So underneath this radical sign, I have the cube root of 5 squared times 5 over here. That is 5 cubed. I can pull these out from underneath the radical sign and say I get a 5. I can pull the y cubed out and call that y. The cube root of z to the 6th power, so I divide 6 by 3, and I get z squared. What's left underneath the radical sign is the cube root of, don't forget the index is still 3, the cube root of, the 2 and the 3 are still there. So 2 times 3 is 6. I might as well just write it as 6. The x squared is still there. So I claim this is the answer to the third problem. 5y z squared cube root of 6x squared. On your homework, I don't think any of your problems ask you to rationalize, but I want to show you how to do it anyways, because sooner or later you ought to know. So number 28 here is an example of dividing two radicals. Number 28 says the square root of 6 times x divided by the square root of 3 times x. Okay, so in this situation, just like when we multiply radicals, we can combine them. When we divide radicals, as long as they have the same index, in this case 2, square root, we can combine them underneath one radical sign. So I could write this as 6x divided by 3x, all underneath the radical sign. And now I see I can simplify it by canceling out the x's and then ask myself, what is 6 divided by 3? Well, 6 divided by 3 is 2. I mean, you could write this as 2 over 1. No one does that. We would say the answer is the square root of 2. That is my answer for number, whatever that was, number 28. Let's do another one. How about number 29? It says, divide and simplify. The cube root of 4x squared divided by the cube root of x. The cube root of 4x squared divided by the cube root of x. Great. Well, because they have the same index, I can combine them underneath the radical sign and say this is 4x squared divided by x. One of these x's will cancel. How do you cancel an x? Don't do it like that. Don't do it like that either. It still looks like an x. Okay, but I know it's canceled. So I have as my final answer the cube root of 4x. Ta-da! Number 31 looks more scary. Now, your homework tonight does not include dividing radicals, but they, do you know how to multiply them? Your homework tonight includes adding or subtracting. So let's try, first I'm going to do number 1, just so that you have a kind of reminder of how you do it. Now, a conjugate means a plus b times a minus b. Here's a, there's b, here's a, there's b, and that pattern means this is the conjugate of that. It can be real numbers, it can be imaginary numbers, complex numbers, but when you do FOIL, so the number is 3 square root of 2 minus 9, close parentheses, open parentheses, 3 radical 2 plus 9, close parentheses. As always, you're going to do FOIL. First 2, outer 2, inner 2, last 2. 3 radical 2 times 3 radical 2 is 9 times the square root of 2 times the square root of 2. Well, the square root of 2 squared is 2. Sorry if I went too fast. For the outer terms, it's going to be plus 9 times 3 is 27 times the square root of 2. When I multiply the inner two terms, I get negative 27 radical 2. These are going to cancel. Every time that you do FOIL on conjugates, the outer and inner terms will cancel. That is the beauty of doing it that way. Now for the last terms, it's negative 9 times positive 9, which is negative 81. So over on the front, I have 18. At the end, I have negative 81. I can combine those terms to simplify it. And 18 minus 81, oh man, I'm too old to do that in my head. 18 minus 81 is negative 63. Ta-da! I claim that's what I get when I multiply these conjugates by each other. Your homework tonight involves adding or subtracting if it's possible. So let's try all of these. Number 4, 9 radical 3. And by the way, I like calling it radical. Even if you call it square root, it means the same thing. So 9 radical 3 plus 2 radical 3. In this situation, they're both square roots of the same radicand. So these are like terms, and yes, you can combine them. This is like saying this is an apple. This is also an apple. So I have 9 times these apples plus 2 times those apples. Well, you can add them together and say I have 11 apples. Okay, so this plus that does combine like that. Number 5 says 5 radical 2 plus 2 radical 3. 5 radical 2 plus 2 radical 3. Turns out, because the radicands are not the same number, this one is an apple, but that one is an orange. And you can't mix apples and oranges. You can't combine apples and oranges. So this one cannot be simplified. This is the answer. It cannot be simplified any more than what's written here. I'm going to do number 6. Number 6 says, what is 3 radical 7 minus 7 cube root of x? What is 3 radical 7 minus 7 times the cube root of x? Apples, oranges. Cannot be simplified. I claim you can't do anything with this. There's the answer. And eventually, if someone gives you a value of x, you plug it into your calculator and you say, oh, here's the answer. Number 7. 14 times the cube root of xy minus 3 times the cube root of xy. All right, now this is easy. Apples, apples. Same radicand and same index. So this is just 14 minus 3 is 11 apples. 11 cube root of xy. Let's do something more interesting, huh? I'm looking at number 14. 14 looks interesting. 14 says, simplify the cube root of 81 minus 3 times the cube root of 3. Simplify. Okay, here we go. When I look at 81, I recognize that 81 is equal to 9 times 9. 9 squared. Well, 9 is 3 times 3, or 3 squared. So 81 is equal to 3 squared times 3 squared, which I can rearrange that and say, oh, that's 3 cubed times 3, which it is. I mean, this is 27 times 3. Okay. So back on this original function here, the cube root of 81, I can pull out a 3 cubed, and what would be left underneath the radical sign is a 3. So the cube root of 81 can be rewritten as 3 times the cube root of 3. This number represents 81. Let me correct that. This number represents the cube root of 81. Now, the second part of this says, subtract from this 3 cube root of 3. So now minus 3 times the cube root of 3. This is an apple. That is an apple. I have 3 apples minus 3 apples. The answer is 0. Oh boy. All right. On your homework, I'm not so sure it's necessary to go back and forth on. I'm throwing these valuable notes in the trash as I go along. I don't know if tonight's homework calls for it, but here's a skill that you ought to have anyways. Because sooner or later, we're going to get there. It says, simplify each expression, assume that all variables are positive, and it starts off with 27 raised to the 1/3 power. 27 raised to the 1/3 power. And really, I should take a glance over in my classroom, and I see Destiny is finally here. Destiny, I'm sorry, but you came along so late that I didn't check to see how long you were trying to get in. You've missed a lot. Good news for you is I'm recording today's session, and so therefore you'll be able to play this to your heart's content. Simplify 27 to the 1/3 power. Well, okay, so any number a raised to the nth power is equal to a to the 1. Oh gosh, the 1 over nth root of a. That is terrible. Don't write that one down. Let's do it this way. The nth root of a is equal to a to the 1 divided by n power. Okay, this is technically correct, but this looks better. Let's do it this way. So when it says simplify 27 to the 1/3 power, another way you could think of that is, what is the cube root of 27? These are both saying exactly the same thing. And so now you should be thinking, oh, okay, I can handle this. I know that 27 is equal to 9 times 3. I know that 9 is 3 times 3. So 27 is 3 times 3 times 3. So the cube root of 27 is the cube root of 3 cubed. Okay, so I could also write that, by the way, 27 to the 1/3 power I could choose to write that as 3 cubed to the 1/3 power. Now, what do you do when you have exponents arranged like this? The answer is you multiply. 3 times 1/3. You don't add them in this situation, you multiply. So 3 times 1/3 is 3/3, which simplifies down to 1. And 3 to the first power is just 3. On your homework that was due last night, they had a question, who was correct? One person said a to the 6th power divided by a to the 6th power is equal to 1. And the other person said any number other than 0 raised to the 0 power is 1. And which person was correct? Both people were correct. One used one identity, and the other person used 2 other identities or properties. So, all right. How would I do number 8? Number 8. Negative 27 to the 2/3 power. Okay, well, we know that 27 is 3 cubed. So this is negative 3 squared. Ha! Did I do that too fast? Okay, so this one is 9. I'm guessing I did that one too fast for you. So negative 27 is negative 3 cubed. Okay, so negative 3 cubed. And we're raising that to the 2/3 power. So again, we are multiplying. This is 3 over 1 times 2 over 3. 3 over 1 times 2 over 3. The 3's cancel, and we're left with just 2 over 1. So this thing simplified down to negative 3 raised to the 2nd power, and that is 9. Here's one that looks horrible. Number 21 looks bad. 21 says, open parentheses, a to the 2/3 power times b to the negative 1/2 power, close parentheses, raised to the negative 6th power. Wow, how do I simplify this one? I would take advantage of the fact that any number a raised to the negative nth power is equal to 1 over a raised to the positive nth power. In other words, x to the negative 2nd power is 1 divided by x squared. And you can check that yourself sometime. So this thing, boy, I guess I would just multiply each exponent by itself. So a raised to the 2/3 power times negative 6. All that times b to the negative 1/2 power times negative 6. So I'm distributing the exponents. I guess I'm using a to the m, b to the n, to some another integer p is equal to a to the mp times b to the np. Okay, so this is much easier, right? 2/3 times -6. Oh, man. Isn't that -4? A to the -4th power times b, -1/2 times -6 is a +3. Now, instead of leaving it as a to the -4 over b to the +3, we prefer that you rewrite this as b cubed divided by a to the 4th power, so that you're listing it as a positive exponent. This was problem number 21 on practice 7-4. Let's go verify that I didn't screw up. Problem 21, the answer is b cubed over a to the 4th power. Ta-da! I'm going to keep pushing. Oh, yeah. A lot of what you have to do on tonight's homework. Let's get to this part now. Extraneous solutions. So when you try to solve a problem, and I'll just start with number 1 here, you're going to be using powers of exponents to do it. What happens is when you raise something to a power, you might be introducing something that looks like a solution, but in reality, it doesn't fit in the original problem. So let's just start with number 1 and get on with this. Number 1, x minus 2, close parentheses, raised to the 1/3 power is equal to 5. We're supposed to solve for x. My first step would be to get rid of that 1/3 power by raising everything to the 3rd power, right? So I'm going to take everything on the left, x minus 2 to the 1/3 power, and I'm going to cube it, because this will multiply times 1/3 and make it a 1. Well, whatever I do to the left, I have to do exactly the same thing to the right. So I have to cube 5. Great. So on the left, 1/3 raised to the 3rd power makes this thing look like x minus 2. And on the right, this is 5 cubed, which I think is 125. And you say, oh, look, this is now super easy. I just add 2 to both sides, and it says x equals 127, but you're not done. You get here. It's not good enough to be here. You have to take whatever answers you think are the answers, and you must plug them back into the original equation and check and see, do they work here? Okay, so in the original equation, if x is 127, then 127 minus 2 is 125. And yes, the cube root of 125 is 5. So after you check it, boop, now you declare this is the answer to number 1. Number 2, 3 times x to the 4/3 power plus 5 equals 53. Okay, number 2. My first step would be to subtract 5 from both sides. 53 minus 5 is 48. On the left, I have 3 times x raised to the 4/3 power. My next step would be to divide both sides by 3. On the left, I have x raised to the 4/3 power. On the right, 48 divided by 3, I forget what that is. 13 maybe? 48 divided by 3, 16. Nice, thank you, calculator. Okay, 48 divided by 3 is 16. Next step, I need to turn this into a 1. So that means I need to raise both sides to the inverse of that. X to the 4/3 power raised to the 3/4 power will give me a 1. On the right, that 16, okay, I'm starting to think 16 is 4 squared. So I'm going to write it as 4 squared. But I have to raise it now to the 3/4 power. On the left, x to the 4/3 raised to the 3/4 power is x. And it seems like life is good. On the right, 4 squared to the 3/4 power is 4 to the 6/4 power, because you multiply. 2 times 3/4 is 6/4. Well, 6/4 is 3/2 is the best way to think of it. 4 to the 3/2 power. The square root of 4 is 2. 2 cubed is 8. So it appears that the answer is x equals 8. Go back to the original equation and ask yourself, what is the cube root of 8? So I'm plugging in x equals 8. I think that's my answer. The cube root of 8 is 2. What is 2 to the 4th power? 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. What is 3 times 16? Well, now I know it's 48. What is 48 plus 5? Oh, that's 53. This one checks. No extraneous solutions. Let's keep going. Let me find one where I know it's going to be an extraneous solution. 7-5. Okay. 7-5. Okay, we're going to do this one. And by the way, feel free to leap ahead of me and solve it on your own and see if I make any mistakes. Number 5. The square root of 2x plus 1 on the left is equal to -3 on the right. My first step, I would square both sides of this equation to get rid of that square root. On the left, it says 2x plus 1. On the right, -3 squared is 9. Oh man, this is child's play. I could subtract 1 from both sides. On the left, I have 2x. On the right, I have 8. Now I divide both sides by 2. X equals 4. Woohoo! But wait, does it work in the original equation? Okay, the original equation said square root of 2x plus 1, is that equal to -3? I plug in x equals 4. The answer I figured out, okay? X equals 4. So the square root of 2 times 4 plus 1. Well, 2 times 4 is 8. 8 plus 1 is 9. The square root of 9 is 3. 3 is not equal to negative 3. There is no answer for this problem. You can't, you can't declare that, oh, you must have made a mistake with plus or minus somewhere, and the answer is x equals 4. Nope. You have to recognize that when we raise things to exponents, sometimes we create what appear to be solutions, but they don't actually work in the original equation. So here's one example like that. Fortunately, this is the end of the new material for today. Everything that I covered will get you through all of today's homework. And I covered a little bit more than what you need for tonight's homework. So technically, I just covered 5 sections of chapter 7 out of this old Algebra 2 textbook. But now for the Wheel of Names. Kiera Fong. Oh, yeah. Kiera.
Yeah, sorry, I had to go get my charger.
Oh, you don't like it? So I have to add your name here 6 more times to this wheel. Oh, yeah. Oh, Kiera.
Yay!
Now, I just did practice 7-5, and before that, 7-4, and before that, 7-3, 7-2, 7-1. Do you want me to work any particular types of problems in our last 3 minutes of class time?
No.
Really?
Yes.
You're no fun. Okay, I'm gonna.
Which one
6 points off from you just for saying that. Well, I'll move on to someone who cares, like Zoe. Hey, Zoe. Zoe.
Roger?
Yes. Okay, Roger.
Radical expression.
Radical expressions. Okay. Like simplifying them.
Yes. Yeah.
Oh, okay, so I'm looking. How about 27? Maybe that looks good. Okay, simplifying radical expressions. Number 27 is an example. It says, simplify the square root of 25 times, open parentheses, x plus 2, close parentheses, raised to the 4th power, all underneath the square root symbol, the radical sign. All right, here we go. 25 is 5 squared. And you students should have, memorized from your multiplication tables, what is 1 squared? What is 2 squared? What is 3 squared? 4 squared? 5 squared? 6 squared? 7 squared? 8 squared? 9 squared? 10 squared? 11 squared? 12 squared? If you still remember what 13 squared is, that's probably as far as you need to go. And beyond that, use a calculator. Great. For x plus 2 to the 4th power, that is x plus 2, squared. Because as I've been trying to show you, in this situation, you multiply the exponents. So simplifying number 25, I can pull out a 5 squared. I can pull out an x plus 2 squared, and I claim the square root of 25 times all that mess is simplified down to that. most of your homework is based on extraneous solutions and adding or subtracting things. So let's close with my 1 minute. No, I'll tell you what. Let's not have you guys freak out. I'm going to pause this recording.